Welcome to Global Byte. Please subscribe and hit the bell icon for more breaking updates. More than 24 billion kilometers from Earth, Voyager 1 drifts in the vastness of space, far beyond the reach of any other human creation. It is a tiny, silent ambassador carrying the hopes and dreams of our species into the unknown, where the sun is just another distant star. Voyager 1 continues its solitary journey through the darkness, venturing into regions no spacecraft has ever explored. Each second, it moves farther from home, into the uncharted territory between the stars. This relic of the 1970s has traveled farther than any human-made object, carrying our curiosity into the unknown. Launched with technology now considered primitive, it endures as a testament to human ingenuity and the relentless drive to explore. In late 2025, after a tense silence that left scientists anxious, Voyager 1 sent back a message that would change our understanding of the cosmos forever. The world held its breath as the faint signal arrived. It revealed not a cold, empty boundary, but a wall of unimaginable heat at the edge of our solar system, a blazing frontier, where the solar wind collides with the interstellar medium, creating a barrier no one expected. This single transmission, taking nearly a day to reach us, is more than data. It's a symbol of human resilience and wonder. It's a reminder that even across the gulf of space, our questions can find answers. Voyager 1's latest findings have shattered old models, showing a turbulent, superheated frontier where the sun's influence ends. The edge of our solar system is far more dynamic and violent than we ever imagined. As we study these signals in 2026, we're reminded that the universe is always more surprising than we imagine. Each new discovery opens doors to questions we never thought to ask. The story of this discovery is one of near disaster, brilliant recovery, and a revelation that will echo for generations. Voyager 1's journey is a testament to our enduring spirit of exploration, and a promise that our search for knowledge will never end. Voyager 1's story began in 1977, at a time when humanity was just beginning to dream of exploring the farthest reaches of our solar system. The world watched in awe as this small, ambitious spacecraft prepared for a journey that would ultimately redefine our understanding of the cosmos. Launched during a rare planetary alignment, Voyager 1 was given a unique opportunity, an interplanetary shortcut that allowed it to visit both Jupiter and Saturn in a single grand tour. This alignment, occurring only once every 176 years, made the mission possible. Its mission was a masterpiece of engineering and vision, using gravity assist to slingshot from one giant planet to the next. Each maneuver required precise calculations and flawless execution, pushing the boundaries of what was thought possible at the time. Voyager 1 revealed Jupiter's swirling storms, including the iconic Great Red Spot, and captured the first close-up images of volcanic eruptions on Io, one of Jupiter's most mysterious moons. Then, as it soared past Saturn, it unveiled the intricate beauty of Saturn's rings and peered through the thick, hazy atmosphere of Titan, transforming our view of the outer planets and revealing worlds more complex than we had ever imagined. After Saturn, its mission changed forever. Voyager became our first interstellar pathfinder, setting its course for the edge of the sun's influence, venturing into the vast, uncharted territory beyond the planets. On board, it carries the golden record, a message in a bottle for the cosmos, filled with sounds, music, and images from Earth. This golden disc is a greeting to any intelligent life that might one day find Voyager drifting among the stars. In August 2012, Voyager 1 crossed into interstellar space, becoming the first human-made object to leave the solar bubble and sample the particles and magnetic fields between the stars. A historic milestone for science and exploration. Every signal it sent back was like a postcard from the unknown, carrying precious data across billions of miles, and setting the stage for the dramatic events of 2025 that would capture the world's imagination. Its journey is a testament to human curiosity, ingenuity, and the relentless drive to explore. Generations of scientists and dreamers have been inspired by Voyager's Odyssey. Voyager's Odyssey continues to inspire us all, reminding us that the universe is full of surprises, and that our quest for knowledge will always carry us beyond the horizon, into the unknown. For nearly 5 decades, Voyager 1's faint signal was a constant in the cosmic wilderness, until October 16, 2025, when it suddenly went silent. NASA's Deep Space Network was met with an unnerving void. The probe's main transmitter had failed. Billions of kilometers away, something had gone wrong, plunging the mission into crisis. At JPL, the loss was deeply personal. Voyager is more than a machine, it's a legacy. The spacecraft's fault protection likely shut down non-essential systems, leaving Earth blind. With each command taking nearly 2 days for a round trip, troubleshooting was agonizingly slow. Weeks passed with no response, and the world held its breath. Had Voyager finally succumbed to the harshness of interstellar space? The silence was profound, forcing the team to confront the possibility that the mission was over. Yet, hope persisted, a testament to the dedication of those who refused to give up. As hope faded and options dwindled, JPL engineers faced a daunting challenge. With Voyager silent, they turned to the spacecraft's backup, a dormant S-band transmitter that hadn't been used since 1981, quietly waiting in the cold darkness of space for over 4 decades. No one could say for sure if it would still function after so many years exposed to the harsh environment of deep space. The backup transmitter was their last hope, a relic from another era, and the only remaining lifeline to Voyager. On October 24, 2025, with tension thick in the air, the team sent the command to wake the S-band. They watched their screens, waiting anxiously, knowing that everything depended on this single attempt. Nearly a day passed in suspense. Then at last, a faint signal appeared on their monitors. Voyager was alive, reaching out across the void. Relief and joy swept through JPL. The backup system, untouched for 44 years, had worked flawlessly, a testament to the original engineers' meticulous planning and the resilience of their design. The S-band's data rate was painfully slow, transmitting only a trickle of information at a time. But even this limited connection was a precious lifeline, allowing the team to re-establish contact with their distant explorer. Diagnostic data began to arrive, bit by bit, revealing the probe's health and the nature of the fault that had silenced it. Each byte of information was a small victory. The original engineer's foresight had saved the mission, bridging 5 decades of exploration and connecting generations of problem solvers at JPL. Hearing that signal was one of the most triumphant moments of my career, said mission manager Bruce Wagoner, recalling the tension and elation of that day. The team proceeded with caution, carefully monitoring every response. Voyager was talking again, but the road ahead would require patience and ingenuity. This recovery was more than just a technical achievement, it was a triumph of engineering, perseverance, and the enduring human spirit. Against all odds, humanity's farthest explorer was back, continuing its journey into the unknown, carrying our hopes and curiosity ever deeper into the cosmos. With communications restored, Voyager's data revealed a shocking truth. The edge of our solar system is a blazing frontier. The probe detected plasma heated to 30,000 to 50,000 Kelvin, hotter than the sun's surface. For decades, scientists pictured the heliopause as cold and calm. Voyager found a violent, superheated boundary. The term wall of fire quickly caught on, capturing the drama of this discovery. This plasma isn't like fire on Earth, it's incredibly thin, so Voyager isn't in danger of melting. The finding upended our cosmic map, forcing a fundamental rethinking of the solar system's edge. Dr. Alara Vance, a lead scientist, recalled, "The temperatures were off the charts. We thought it was an error, but the data was real." The boundary was not a gentle shore, but a furnace. Voyager's discovery sent ripples through the scientific community. Our cosmic shoreline was far more dynamic and dangerous than anyone had imagined. The universe had once again surprised us. What could create such extreme heat at the solar system's edge? The answer lies in the clash of charged particles and magnetic fields. The heliopause is where the solar wind meets the interstellar medium, a turbulent battleground, the main culprit magnetic reconnection, where magnetic field lines snap and realign, releasing bursts of energy that superheat the plasma. Voyager found abrupt shifts in particle density and magnetic fields, revealing a patchy, chaotic frontier. The interstellar magnetic field presses hard against our heliosphere, squeezing and heating the plasma. It's a natural particle accelerator, explains Dr. Kenji Tanaka. The sun's magnetic field acts like a cosmic slingshot. These collisions generate the intense heat Voyager measured. For the first time, we're seeing how a star's bubble interacts with the galaxy, a universal process. Voyager has given us a front-row seat to the fundamental forces shaping the cosmos. Voyager's discovery has redrawn our map of the solar system's boundary. The heliopause is no longer a smooth, quiet line, but a turbulent, energetic coastline. The interstellar medium doesn't just flow around us, it presses in, creating zones of intense heat and pressure. Magnetic fields, once thought to be misaligned, were found to drape over the heliosphere, adding complexity to the boundary. This new understanding changes how we think about our protection from cosmic radiation. The interaction between our sun and the galaxy is a dynamic struggle, not a passive shield. It's stormy and chaotic, says Dr. Vance. We're seeing the weather at the edge of the solar system. This forces us to reconsider how other planetary systems are shielded from their environments. Voyager has opened a new field: interstellar meteorology. Voyager 1's revelations go far beyond our solar system. By directly measuring the heliopause, it's turned theory into reality, providing a laboratory for plasma physics and magnetic fields. The data is a ground truth for models of how stars and galaxies interact. Understanding the heliopause is crucial for future interstellar missions. Any probe leaving the solar system must survive this turbulent region. Voyager is a scout, mapping hazards for future explorers. Its findings help us understand astrospheres around other stars, key to assessing exoplanet habitability. Voyager has given us a Rosetta Stone for astrospheres, says Dr. Tanaka. We can now predict the environments around distant stars, with huge implications for the search for life. Voyager's legacy is a paradigm shift in how we view the cosmos and our place within it. Voyager 1 is a symbol of humanity's curiosity and perseverance. Its journey and discoveries remind us that there are always new frontiers to explore. When you look up at the night sky, remember, a piece of humanity is out there, still working, still discovering. By following missions like Voyager, we keep the spirit of exploration alive. The universe challenges us, but in meeting those challenges, we grow. Voyager's story teaches us to stay humble and keep questioning. One day, its power will fade, but its journey will continue, drifting through the Milky Way for millions of years. It carries the golden record, a greeting from Earth, waiting to be found. Its true legacy lives on in the knowledge, technology, and wonder it inspires. Keep looking up. The cosmos awaits.